All right, so find a fourth degree polynomial with integer coefficients and with zeros of radical 3 and 2i. Okay, so it's a fourth degree polynomial which tells us that we need four solutions, right? And well, if you read the question, we're given two of them, right? We know that x is radical 3 is one of the answers. We also know that x equals 2i is one of the answers. So what are the other two solutions? Okay, and the key to remember is that irrational, right? Irrational and complex solutions always come in conjugate pairs. Okay, what is a conjugate of radical 3? It's negative radical 3. So we can conclude that x equals negative rad 3 is also a solution. Similarly, if x equals 2i is a solution, then x equals negative 2i must also be a solution. So there we go, right? Now we have all four zeros. Right? So the next thing we want to do is we want to write this in this factored, the factored form. Okay, so x plus radical 3 equals 0, x minus radical 3 equals 0, x minus 2i equals 0, x plus 2i equals 0, and then we want to multiply these factors together. And once we do so, we should get our polynomial. You notice there's no other initial conditions or anything else, right? So we'll multiply this out, we should get our answer. Right? Remember, but these are conjugates. So when we FOIL these, it turns out pretty nice, right? What do we get in this case? We get x squared minus 3. Okay? What about when we multiply x minus 2i times x plus 2i? Okay? We get x squared plus 4. Okay? And now we can just FOIL or distribute or multiply these out. We can FOIL this, and we should get our final answer. Right? We get x to the fourth plus 4x squared minus 3x squared minus 12. And when we combine these terms, right, we get x squared, x to the fourth plus x squared minus 12. And this should be our final answer here.